Hello everyone, welcome back to our session on operational research. The topic that we are going to study today is assignment model. So let us assume we have n number of jobs and we have n number of persons who are competent enough to do those jobs. Obviously, the degree of efficiency will vary person to person, but let us assume we have n number of jobs and we have n number of competent persons who can do those particular jobs. Now, what we need to do is we need to assign the jobs to these person in such a fashion that the cost of assignment is minimized. The cost of assignment is minimized. In short, assignment model or assignment problem is a minimization technique of optimization. We know that in operational research we do optimization. So assignment model can be said as a minimization technique in which we minimize the cost of assignment. Okay, so assignment models can be categorized into two types. We have balanced assignment model, and unbalanced assignment model. So the assignment model is generally represented in a matrix. So if the number of rows of a matrix is equal to number of columns, then we can say that the assignment model is a balanced assignment model. And when the number of rows and number of columns are not equal, then it can be said as a unbalanced assignment model. The method which is used to solve the assignment model is called as Hungarian approach or Hungarian method. Okay, so there are certain steps which are adapted for solving the assignment model. The first important step is to check for balanced assignment problem. Means we need to make sure that the assignment model must be balanced. If it is not, we need to convert the unbalanced to balanced one. The next important step is row reduction. Which is followed by third step, that is column reduction. Once the row reduction and column reduction is finished, we can go for row and column scanning. Once the scanning is done, we can check the condition for assignment. So the condition of assignment is the assignment can be done only if the number of lines is equal to order of matrix. Now what exactly is number of lines? We will understand it with the help of numericals. But if number of lines capital N is equal to the order of matrix, we can go for assignment. If not, if n is not equals to small n, we need to make some correction and again check for assignment. So this is all about Hungarian method or Hungarian approach. Now let us understand this particular Hungarian method with the help of a numerical. Okay, so you can see on your screen there is one numerical in which we have 5 machines A, B, C, D, E, and we have 5 jobs 1, 2, 3, 4, 5. Okay, so here we have a matrix in which number of rows represents number of jobs, whereas number of columns represent the number of machines. And what we are supposed to do is we are supposed to assign the jobs to those machines. Each job can be assigned to a particular machine. The assignment is done in such a way that the cost should be minimized. So in short, in this particular matrix, each cell value represents the cost of assignment. So this is again a minimization problem. So let us start. So we have already seen that the first important step is to check whether the problem is of balanced or unbalanced assignment. So here we can say that number of rows equals to number of columns. So number of rows, that is 5, is equal to number of columns. Therefore, it is balanced problem. Balanced assignment model. Okay, so now we can go for row reduction. So we can proceed to the next step, that is row reduction. Now listen carefully. What exactly we mean by row reduction? So if we see in the first row, we have 5 cell values 13, 8, 16, 18, 19. Now row reduction means that we have to select the minimum value from the first row. Okay, so if we see in the first row, the minimum value is 8, and we need to subtract this minimum value from all other cell values of row 1. Let me repeat it once again. For reduction or for row reduction of the first row, we will select the minimum value in that row and we will subtract that value from all other cell values. So now we have in the first cell, the value we will get will be 13 minus 8, that is 5. In the second cell, we will have 8 minus 8, that is 0. 16 minus 8, that is 8. 18 minus 8, that is 10, and 19 minus 8, that is 11. So the row reduction of first row is already done. Now let us move towards the next row. In the next row, we have 9 as a minimum value. So we will subtract 9 from all other values of that particular row. So we have 9 minus 9 as 0, 15 minus 9 as 6, 24 minus 9 as 15, again 9 minus 9 as 0, and 12 minus 9 as 3. Let us proceed to the third row. We have 4 as the minimum value. So 12 minus 4 is 8, 9 minus 4 is 5, 4 minus 4 is 0, 0, 0. In the fourth row, 6 is the minimum value. So we have 6 minus 6 as 0, 12 minus 6 as 6, 10 minus 6 as 4, 8 minus 6 as 2, and 13 minus 6 as 7. And in the final row, we have 12 as the minimum value. So we have 15 minus 12 as 3, 5, 6, 0, and 8. So we have completed our step number 2, that is row reduction. Now let us proceed to the next step, that is column reduction. Now, as in the row reduction, we have selected the minimum value in that particular row and we have subtracted that value from all other values. In column reduction, we will follow the same procedure, but now this time we will select the minimum value from column. So in the first column, the minimum value is 0. If we subtract 0 from all other values, we will get the same value. So 5 minus 0 is 5, 0 minus 0 is 0, 803. Now again in the next column we have 0 as the minimum value. So 0 minus 0 is 0, 6 minus 0 is 6, 5, 6, 5. In the third column the minimum value is 0. So we will subtract the 0 from all other cell values from that particular column. We will get the values as 8, 15, 0, 4, 6. Follow the same process for column number 4. We have 10, 0, 0, 2, 0, and finally we have 11, 3, 0, 7, 8. So we have completed row reduction and column reduction. Now the next step is we need to do the scanning. Okay, so for that let me write down all the values as it is. So I will write down all the values that I have just achieved at the end of column reduction. Okay, now we will start with row scanning. Okay, so firstly we will do row scanning. Now listen carefully. We will scan the first row and we will identify such a row that the row should consist of only 1 0. If the row consists of 1 0, we will box that row and we will scratch the column. Okay, and then we will move towards the next row. For example, if in any row we have 2 zeros, so we will ignore that particular row and then we will move towards the next row. So this is all about row scanning. Okay, so what we have discussed, we will go from the first row. Now we can see in the first row we already have only 1 0, so we will box that 0 and we will scratch the column. We will box the 0 and we will scratch the column. Similarly, we will move towards the next row. Now in the next row we have 2 zeros, so we cannot box the 0, so we will move towards the third row. In the third row again we have 3 zeros. Again we won't be able to box it. Move towards the fourth row. Now in the fourth row we have 1 0, so let us box the 0 and then we will scratch the column. And again in the last row we have 1 0, so we will box the 0 and we will scratch the column. So we are done with row scanning. Now let us proceed to the column scanning. In column scanning we will scan the column and we will scratch the row. So first column is already scratched, we will ignore it. Second column is also scratched, let us ignore it. In the third column we have 1 0, so now we will box the 0 and now we will scratch the row. Okay, so now if you see, all the zeros are already scratched. Okay, all the zeros are already scratched. So as all the zeros are already scratched, we can say that number of lines, so here the number of lines that we get is 4, is not equal to order of matrix, and the order of matrix is 5. Therefore, no assignment or assignment cannot be done. Okay, so now we need to revise it. Now what are the steps involved in revising? Let's see carefully. There are some points that we should keep in mind. The first point is select the minimum unscratched value. So select minimum unscratched cell value. Here we have, for this numerical, the minimum unscratched cell value is 3. Okay, subtract it from all unscratched value. Okay, so select the minimum unscratched value, subtract it from all unscratched value, and add that value at junction of lines. Junction of lines means wherever two lines have intersected at that particular point, we will add that particular value. Okay, so let us see exactly what we have written. So we have written that we will identify all the unscratched value, and in that unscratched value we will identify the least value. So 3 is the least value. We will subtract that least value from all other unscratched value. So we have 8 minus 3 as 5, 15 minus 3 as 15 minus 3 as 12, 4 minus 3 as 1, 6 minus 3 is 3, 11 minus 3 is 8, 3 minus 3 is 0, 4 and 5. Sorry, 7 minus 3 is okay. Okay. Now we will add that in in junctions. Now let us see where the junctions are. So here this is a junction, here this is a junction, and here also we have it as a junction. So we will add the 3 at those points. So 8 plus 3 is 11, 5 plus 3 is 8, and 0 plus 3 is 3. Okay, all other values will remain as it is. So again we have 5, 0, 10, 0, 6, 0, 0, 0, 0, 6, 2, 3, 5, 0. Okay, so now we are done with the adjustment. So let us begin with again row scanning and column scanning. So in the first row we already have 0, so we will box the row and we will scratch the column. In the second row we have 3 zeros, leave it. In the third row we have 2 0, leave it. In the fourth row we again have 1 0, so we will box the 0 and scratch the column. In the last row we again have 1 0, so we will box the 0 and scratch the column. So row scanning is finished. Now go for column scanning. In column scanning already first and second column are scratched. Now let us move towards the third column. In the third column we have 1 0, so we will box it and we will scratch the row. Fourth column is already scratched, and in the fifth column we have 1 0, so we will box it and we will scratch the row. So now we have number of rows, we have number of lines, that is 5, is equal to order of matrix, that is 5. Okay, so now the numerical is completed. So now therefore we can write down, therefore assignment can be done. Now let us move towards our main problem. So in our main problem we will compare the last table and we will see at what positions the zeros are boxed. So the zeros are boxed at this position, next at this, at this, so here zeros are blocked at 8, 12, 4, 6 and 12. Okay, so we can write as job number 1 can be assigned to machine number B and the cost required is 8 rupees. Similarly, job number 2 will be assigned to machine number machine number E and the cost is 12 rupees. Job number 3 is assigned to machine number C and the cost is 4 rupees. Job number 4 is assigned to machine number A and the cost is 6 rupees. And finally, job number 5 is assigned to machine number D and the cost is 12 rupees. So if we add it, we get the cost of assignment as 42 rupees. Okay, so this is all about minimization. This is all about the Hungarian approach of minimization. I hope you have understood. Now just for practice, let us solve a second numerical. You can see in the second numerical we have 4 professors P1, P2, P3, P4 and we have 4 subjects S1, S2, S3, S4. We are supposed to assign each subject to one of the professor and the assignment should be done in such a way that the cost of assignment is to be minimized. So our step number 1 will be number of rows and number of columns should be equal. So here we have 4 rows and 4 columns. So thus this problem is a balanced assignment problem. Our step 2 will be row reduction. In row reduction, we will identify the minimum value in each row. So in the first row, the minimum value is 2. We will subtract that value 2 from all other values of that particular row. So 2 minus 2 is 0, 8, 7, 5. For second row, we have 4 as the minimum value. So we will subtract 4 from all the elements of that row. So we have 11, 0, 10, 4. In the third row, we have 11 as the minimum value. So 13 minus 11 is 2, 3, 5 and 0. And in the last row, we have 3 as the minimum value. So we will subtract it from the all other cell values. So we will get 3 minus 3 is 0, 12, 10 and 5. So we are done with the row reduction. Now let us proceed to the column reduction. So in column reduction, we will follow the same procedure, but this time it will be for column. So in the first column, 0 is minimum value. So 0 minus 0 is 0, 11 minus 0 is 11, 2 minus 0 is 2 and 0. In the second row, again we will get 8, 0, 3, 12. In the third row, we have 7 as the minimum element cell value. We will subtract it from all other cell values of that particular column. So 7 minus 7 is 0, 3, sorry. In the third row, we have 5 as the minimum value. There is a correction. So 7 minus 5 is 2, 10 minus 5 is 5, 5 minus 5 is 0 and 10 minus 5 is again 5. Next we have 0 as the least element, so we will get 5, 4, 0, 5. Now let us proceed towards the row scanning and column scanning. So we will write down the cell values as it is. So we have 0, 8, 2, 5, 11, 0, 5, 4, 2, 3, 0, 0, 12, 5, 5. Again, as usual, we will see in the first row we have 1 0. So we will scratch the 0 and we will box the 0 and scratch the column. In the second row we have 1 0. So we will box the 0 and scratch the column. In the third row we have 2 0. So leave it. In the fourth row we don't have any 0. So row scanning is completed. Now let's proceed to the column scanning. First 2 columns are already scratched. Those move toward the third column. So in the third column we already have 1 0. So box it and scratch the rows. Now we can see that all the zeros are already sketched, either scratched or boxed. So we can write that number of lines are not equal to order of matrix. That is 3 is not equal to 4. Therefore, assignment cannot be done. Okay, so as we have seen previously, what we will do is we will identify the least unscratched element. So here the least unscratched element is 2. We will subtract that 2 from all other unscratched elements. So 2 minus 2 is 0, 5 minus 2 is 3, 5 minus 2 is again 3, 3, 2, 3. Okay, and we will add that particular 2 in all the junction points. So junction point here is 2 and 3, where the two lines intersect. So 2 plus 2 will be 4 and 3. Remaining element will be written as it is. So we have 0, 8, 11, 0, 0, 0, 0 and 12. So now again we will repeat the row scanning. In the first row we have 2 zeros, we cannot box it, move towards the next row. In the next row we have 1 0, we will box it and scratch the column. In the third row we have 2 zeros, leave it. In the fourth row we have 1 0, we will box it and scratch the column. So we have already finished the row scanning. Now move toward the column scanning. First two columns are already scratched, so move towards the third column. In the third column we have 2 zeros, so we cannot do anything. Move towards the fourth column. In the fourth column we only have 1 0, so we can box it and we can scratch the row. So now row, column and column scanning are already done, but still we have 1 0 which is not boxed as well as not scratched. So now we will repeat the process. We will again go for row scanning. Now see, in the first row we have 1 0, so we will box it and we will scratch the column. So now all the zeros, scratching of all the zeros is done. So we can say that number of lines is equal to order of matrix. So 4 equals to 4. Therefore, assignment can be done. Now let us compare this matrix with the initial problem and we will identify the points. So in the first row this position is boxed, in the second row this position is boxed, in the third row this, and in the fourth row this. Okay, so we can summarize as professor, subject and cost. So professor P1, P2, P3 and P4. Professor P1 will be allotted subject number 3, where the cost will be 9 rupees. Professor P2 will be allotted subject number 2 with the cost 4 rupees. Professor P3 will be assigned subject number 4 and the cost will be 11 rupees. And finally Professor P4 will be assigned the first subject where the cost is 3 rupees. Okay, so the total cost here will be 27 rupees. Okay, so this is all about assignment model. In the next lecture we will see about certain variations in assignment model like maximization problem or restricted assignment.